prepared.
I don't know. It might be interesting. Let's not know it.
All right, let's graph this. I like to be really careful when I've got my fractions involved here. So I'm going to do parentheses x caret 3 plus x parentheses divided by x. So I'm going to be super careful with my parentheses. And I'm going to go graph it. I would be in a normal window. The problem here is you probably can't see what's going on. We see like a parabola, right? I'm going to zoom in. As I get closer and closer to my y-axis, I can see on this calculator that I've got essentially a hole at that axis. Here's my graph. There it is. I've got a hole at that x-axis. What happens here is that the denominator cannot equal 0. And so if I plugged x in for 0, I would not have a point. So I have a discontinuity of missing 1 point. What do we call that discontinuity? What was the one where we just took 1 point out? Not jump. Removable discontinuity. Removable discontinuity. Again, we are going to do rational functions in a little bit. That we'll not get to that today, but next week we'll talk about that, and we could have seen that from there. Now let's do the other one too. I'm going to go back to y equals, and I'm going to make that x divided by, this time I'm going to put parentheses around the denominator, x minus 2. And I'm going to graph it again. Now what does this one look like? Wait, Ava, what'd you say? Nope.
It's infinite.
An infinite discontinuity. Infinite discontinuity. I'm going to sketch it on my note sheet and then I'll show you guys. So anytime it looks like that, it's an infinite discontinuity. I know. We're dropping rapidly by the minute. I just keep touching the native supplement on, so let me get off my phone. All right. This is what I wrote on my paper to kind of represent what we just did on the calculator. Again, we will explore more of these so you can identify the types of discontinuity, and we'll talk about asymptotes in a little bit. But I want to go back to number 2. That's a problem that's kind of like the BFF graphs that we have been doing. And it's asking us like symmetry and boundedness and all that stuff on the graph that we have to sketch. So when you're done with this, jump back to number 2, and that will be the last one that we do for today. Okay? Jump back to number 2. All right, so on number 2, it says consider this, and it gives us an equation. Okay, what kind of equation is this? Absolute value. And what do absolute values look like? Like a V, right? A straight V on both sides.
Yeah.
What does this minus 1 do to my V? Y value at -1, it's going to go down 1. And what does the 2 do? Left 2. We want it to go to the right 2. It does not do what we want it to do when it's inside, so it goes opposite what we think. It goes to the left 2. So we're going to go graph this on our graph over here. I'm going to make sure I go left 2 and down 1, somewhere in there. I'm going to graph a straight line going outside of it, something similar to that. Graph a straight line coming this way. Perfect. That looks good enough. It's not ideal, but we know what it is. Close enough. All right, we're going to use that. Now, if you weren't sure, you could have also put this in the calculator and graphed it, and it would have given you the same thing. All right, so let's answer these. Is that continuous? Yeah, we can graph that without picking up our pencil. All right, increasing, decreasing. That's one of the harder things that we've been doing. Remember, that's as we go across the page from left to right, what my graph is doing. So as I start from the left side, what's my graph doing? until
No, negative 2.
decreasing from negative infinity to -2. We always care about the x value, not the y, the x. Then I'm going to start increasing, and I'm increasing from what to what?
Negative 2 to infinity.
-2 to infinity. I think I've talked about this. I like to use parentheses here because technically -2 is in both of those. And at -2, nothing is specifically happening. It's where the change happens. If you put brackets, we're at a place in our math career that I'll accept that. If you were to go more advanced in math, that would not be okay. But I just am guiding you to the right thing, not being super critical about those little things. All right, boundedness. Bounded above, bounded below, bounded both, not bounded. What's going on here? Why would you say below? Why is it not bounded below? Good. Bounded below means that there's a floor that we never go below. So that means that every point cannot go below this part of my graph. And that's true. My V stops at -2 and never goes below it. If it's bounded above, that means that there's a ceiling that I can never cross. If I had like one of those parabola work problems that we were doing where it reaches like a height and then it comes back down, that's bounded above because never ever will it cross that ceiling. It will always stay below it. So we're going to say this is bounded below. All right. What about asymptotes? When do we have asymptotes? Do you remember what are any of the functions that do have asymptotes? Reciprocal does. The weird one, the logistic one. I don't love the logistic one, but I'll write it down here too. Exponential has asymptotes, and natural logs have an asymptote. I believe none of the other ones have asymptotes, so that's something that sometimes I just remember. Like I know absolute value does not have asymptotes just by definition, so I know my answer here is none. There are none, no, NA, whatever makes you happy to write there. All right, are there any extrema? Are there any maximums, minimums, anything? Let's write it as an ordered pair, -2, -1. So we've got a minimum there. Do we have any maximums? Nope. Nothing is way higher, way lower than everything else. All right, symmetry. I know we talked about even and odd symmetry, but when I'm doing like adjustments, like going left and going up and going down, I just want us to say, yes, it's symmetric or no, it's not symmetric. So does this graph, I don't mind, doesn't look symmetric, but is it supposed to be symmetric? Yeah. No, we will just say yes. We're not going to say even or odd because even or odd have to be reflected about the axis and we're not around the axis. All right, I've got domain next. What's my domain for this graph? Good, -infinity to infinity. While I'm looking here, what about my range?
-1 to
-1 to infinity. Very good. -1 is my lowest x, or my lowest y. I hope I said that last class. I'll fix alpha. -infinity to positive infinity, and my range is -1 to positive infinity. All right, next I've got zeros. The zeros on my graph, let's go look. One of the reasons my graph is a little wonky is because I wanted to make sure that I went through -1 and -3. I don't know if you guys learned about like the basics of drawing an absolute value, but you always go over 1, up 1 every time you do a little stair step. So we're always stair stepping over 1, up 1. So I just wanted to make sure I hit those points. So I could just use my knowledge of the pattern of an absolute value to know my zeros are at -1, +1. You also could graph your equation in the calculator and find out like the zeros by doing second trace zero, all that kind of stuff. So my zeros are -1, -3. Okay. All right, I think that's good for today. You do not have homework. Those graphs need to be done by Wednesday, so maybe you can start looking at your graphs now.